Find the center of mass of the uniform lamina ABCDE shown in the diagram. So we have this diagram, okay, and what we can find, okay, is that uniform lamina ABCDE is a composite lamina. Okay, so this is composite lamina, okay, because it is made from two different lamina. Okay, so I'm writing is composite lamina made of two uniform lamina. Okay, one square lamina ABDE, two triangular lamina BCD. So we have this. Now we can see in this diagram, okay, this line, this horizontal line is dividing the composite lamina into two equal parts. So this line represent the axis of symmetry. Okay, so this represent the axis of symmetry or line of symmetry. So we have this. Okay, so what we find, the composite lamina is symmetrical about this axis. So I'm writing over here, the composite lamina, okay, and we find the composite lamina is made from square lamina. Okay, so it is also symmetrical about this axis, and triangular lamina is also symmetrical about this axis. So we find this. Okay, the composite lamina is symmetrical. Okay, it is symmetrical about the axis of symmetry. So the mass is uniformly distributed about the axis of symmetry. So the center of mass, okay, so I'm writing in this way. So CM is the center of mass. Okay, the center of mass lies somewhere on the axis of symmetry. So this is very important point. Okay, the center of mass lies somewhere on the axis of symmetry, and what we find, the axis of symmetry is horizontal. Okay, so it is horizontal. So what we find, center of mass lies somewhere on this line. Okay, it lies somewhere on this line. So we have this. So for convenience, okay, I'm drawing in this way. This is y-axis. Okay, so we have this, and this point is the origin. Okay, so this is the origin. So we have this. So as I said earlier, center of mass of this composite lamina lies somewhere on this horizontal line. Okay, that is on the axis of symmetry. So what we find is that the y coordinate of center of mass of this composite lamina is 0, because center of mass lies on the horizontal line, that is, it lies only on the x-axis. So in this figure, okay, what we find, y coordinate of center of mass is 0, okay. So we have this. So this is to be noted, okay. So let center of mass of uniform lamina be at this coordinate, okay. So as I said earlier, y coordinate is 0. So we can write in this way. So this equals x bar 0. So we have this. Okay. So we need to find the x coordinate of center of mass, okay. So this is to be noted, okay. So we have this. Therefore, we find x bar, that is x coordinate of the center of mass of the composite lamina. So we have this. Now what we do before going into the calculation, okay, let us suppose rho, okay, this is mass per unit area of the lamina. Clear? And we need to note that, okay, we need to note that mass equals area times rho. Let us find or simplify this product, okay. So what do you get? Area times rho. And what is rho? It is mass per unit area. Therefore, this product gives the mass. So we need to understand this, okay. So this is to be noted. So when we multiply rho with area, then we get the mass. So this is important point, okay. Now I have the same diagram, okay. What we do, as I said earlier, okay, we have composite lamina A, B, C, D, E. And this composite lamina is made from square lamina and triangular lamina. So first what we do, okay, we take uniform lamina A, B, D, E, and this is uniform square lamina. Okay, and we find its mass and center of mass. Now, how we find its mass? So as we did earlier, okay, mass of lamina A, B, D, E, or let me write in this way. lamina ABDE. So this equals area of ABDE times rho, and rho is mass per unit area, and the area, okay, of this square lamina is 2A times 2A, and we have rho. So therefore we can write, okay, mass. Therefore we can write mass of lamina ABDE equals 4A square rho. So I'm writing in this way, okay. Mass of ABDE equals 4A square rho. So we have this. Okay, we have this. Now what we find, this is square lamina, okay. This is square lamina is uniform. It is uniform lamina, okay. So we have this, and this is the axis of symmetry. So we find, okay, its center of mass. So center of mass of uniform square lamina ABDE lies at its geometrical center. So this is to be noted, okay. And what is the geometrical center? You see, this length is 2A, clear? So let me draw in this way, okay. This is y-axis as we did earlier, okay. So we are taking this, clear? So this point is taken as origin, okay, and this horizontal length, okay, this is twice A. So this is A, clear? And we know center of mass is lying on the axis of symmetry. Therefore, we have x coordinate of this square lamina, that is center of mass, x coordinate is A, and its y coordinate is 0. So center of mass of uniform square lamina ABDE lies at its geometrical center. So the center of mass for or of lamina ABDE is A comma 0. So we have this. So this is the center of mass. Clear? So putting this inside a box, okay. So we have this. Clear? Now what we do next, we take uniform lamina BCD, and this is triangle in shape, okay, or it is triangular. It is a triangle. So let me write in this way, okay. It is triangle. So we have this. Now we find its mass, okay. So mass of lamina BCD, this equals area of BCD times rho, and we know area of triangle BCD, okay, is half times its base, and base is DB, okay, this is base. So it is twice a half time, area of triangle. So I'm writing over here, area of triangle is half times base times height, okay. So the height is thrice a, and we have rho. This cancels. Therefore, mass of lamina BCD equals 3a square rho. So we have this. Okay, this is to be noted. We find center of mass, okay, of uniform triangular lamina BCD. So I'm writing in this way, center of mass of lamina BCD, okay. Before finding this, okay, let us understand this concept. Triangle, okay, so I'm denoting symbolically, triangle center of mass lies at the point of intersection of the median of triangle. So this is to be noted, okay, and the median of triangle intersect at 1/3, okay, intersect 1/3 from the base to the vertex of triangle in any median, okay. So I'm writing in short, okay, the median of triangle intersect at 1/3 from the base to vertex on any median. So this is the median, okay, this distance is the median, okay. So we have this here. Now this is the base of the triangle, base of triangle BCD. I can draw median also in this way. So this median, it is acting like median, this median and this median, they intersect at this point, okay. So the center of mass of this uniform triangle lies at this point. So we have this, okay. So this distance is this is 1/3, okay. This distance is 1/3 the height of the triangle. So we have this, okay, this distance. So it gives me A. So let me write in this way. This distance is A. Clear? So this is A. We have this 1/3 times 3A. That is height of the median or distance from base to the vertex of the triangle. So we have this. Clear? Now what we do is that, okay, we find the center of mass of this uniform triangular lamina, and we are finding center of mass from this point, okay? So it is acting like origin. Clear? So this length, total length is, we can see this is twice A and this is A. Therefore, the center of mass of triangular lamina is at thrice A, comma 0. Okay? The y coordinate of center of mass is 0 because center of mass lies on the axis of symmetry. So the coordinate for center of mass for lamina BCD, that is triangular lamina, is 3A, comma 0. So we have this. Okay. So this is to be noted. Okay. Now we use this relation, okay, to find center of mass of composite lamina. We use the relation. Okay? We use this relation, summation, okay, mn xn equals x bar, that is x coordinate of center of mass, and summation mn. So we have this. Now what we find, okay, we have this, okay. So for square lamina, okay, the mass is 4A square rho. Its mass is 4A square rho, and its center of mass is at its geometrical center, okay. So we have this. This is x, this is y, okay, this is, let's say, origin. So we have this. Clear? And for triangular lamina, okay, its mass is 3A square rho. Its mass is 3A square rho, and its center of mass, okay, is having coordinate 3A, comma 0. So the coordinate for this triangular lamina, that is center of mass, is at 3A, comma 0. So we have this. So what we do now, using this relation, okay, we write in this way: 4A square rho times the x coordinate of its center of mass, that is for square lamina, this is A, plus, now for triangular lamina, mass is 3A square rho times the x coordinate of center of mass for triangular lamina. So it is 3A equals x bar, that is x coordinate of center of mass of composite lamina, times total mass of the composite lamina, okay. So summation m, this gives me the total mass of the composite lamina, or we need to add mass of square and triangular lamina to get the total mass of composite lamina. So we have 4A square rho plus 3A square rho. Now we have this, okay? Therefore, we can write x bar equals 13 AQ row by 7A square row. So this cancels out. Let us simplify this, okay? So we get 13A by 7. Therefore, okay, the x coordinate of center of mass of uniform lamina. So it is A, B, C, D, E. A, B, C, D, E is 13A by 7. Or we can write in this way, center of mass of uniform lamina A, B, C, D, E equals, this is 13A by 7, comma 0. So we have this. Okay. As I said earlier, we need to find only the x coordinate of center of mass, because center of mass is lying on the horizontal line, that is along the x-axis. We are going to tabulate the result obtained, okay? And we have calculated mass of square lamina, okay, is 4A square row, and its center of mass is at A, comma 0. So the mass is 4A square row and center of mass is at A, comma 0. And the mass of triangular lamina is 3A square row and its center of mass is at 3A, comma 0. So its mass is 3A square row and center of mass is at 3A, comma 0. So this is Y and this is origin O, okay? Y and X axis, they intersect at this point. So we have this. Now, what we find, composite lamina, okay, A, B, C, D, E is made from square lamina A, B, D, E and triangular, okay, I'm using this symbol, lamina B, C, D. So these two lamina, okay, are added to get a composite lamina. So what we find in this table is that portion A, B, C, D, A, B, D, E, sorry, A, B, D, E and portion B, C, D are added to get a composite lamina. Clear? So we have this. So I'm writing in this way. I'm using plus sign to indicate that we need to add portion A, B, D, E. Okay. So A, B, D, E. This is added with portion B, C, D to get composite lamina A, B, C, D, E. Okay. We are using plus sign just to make clear that we need to add these two portions to get a composite lamina A, B, C, D, E. So we have this. and the mass, okay, of this portion is 4a square rho, and mass of this portion is 3a square rho. Clear? And we know the y coordinate of center of mass is 0. So I'm writing in this way, okay, directly. And the x coordinate of center of mass for this portion is a, and the x coordinate of this portion, center of mass, is 3a, okay. The x coordinate of center of mass for this portion, that is triangular lamina, is 3a. Now when we multiply mass with x, okay, so we have this 4a square rho times a, and we have this 3a square rho. So we are multiplying mass with x, okay. So we have 3a. We are not finding the y coordinate of center of mass because it is 0, okay. And when we add this, it gives me the total mass 7a square rho. So the x coordinate of center of mass is x bar, and we know y bar, that is y coordinate of center of mass, is 0. So I'm not writing over here, okay. And we know, okay, we have used this equation. See, summation mn xn equals x coordinate of center of mass times summation mn. So when we add these two, okay, term, then what we get this, okay. We get this result, or we can write in this way also directly, okay. So this is 7a square rho times the x coordinate of center of mass. So in this way, we find the center of mass of the composite lamina.